Two chips are quietly rewriting how the world moves power.
Meet silicon carbide and gallium nitride. A band gap is the energy wall an electron must climb. Silicon sits near 1.12 electron volts. Silicon carbide jumps to about 3.26. Gallium nitride sits near 3.4. Their critical electric field is roughly 10 times silicon. Same blocking voltage, thinner drift layer, lower loss.
Silicon IGBTs leave a current tail when they turn off. Silicon carbide MOSFETs switch clean. No minority carrier tail.
Gallium nitride rides a two-dimensional electron gas. Crazy fast switches, especially below about 650 volts.
They are teammates, not rivals. Gallium nitride loves high frequency at lower voltage. Silicon carbide owns continuous high power at higher voltage.
800-volt EVs lean hard on silicon carbide traction inverters.
AI factories are pushing toward 800-volt DC power trees.
And your tiny wall charger? That shrank on gallium nitride.
Analysis that you'll see power silicon carbide devices near $11 billion by 2031, and power gallium nitride near $3 billion by 2030.
But today, the silicon carbide supply chain is digesting overcapacity. About 50% utilization upstream, 70% on device lines.
The path runs from powder and crystal boules to wafers, epitaxy, devices, modules, then cars and data centers.
Public names include Infineon, STMicroelectronics, onsemi ROHM, Wolfspeed, Navitas, and Coherent. This is a map of exposure, not investment advice.
Wolfspeed filed Chapter 11 on June 30th, 2025, and emerged September 29th, cutting roughly $4.6 billion of debt.
Quick reminder, this video is education only, not investment, financial, or legal advice. Always verify primary sources.
If this helped, tap like, subscribe for more deep dives, and drop a comment on which chip you want next.